So we will talk today about Radware in general, but from a different angle. I want to speak about attacks that we are seeing in Radware, in our scrubbing center around the world, what intelligence we are seeing over there, what kind of attacks. We'll speak about the attacker's point of view, what type of attacks they are generating, what is different and what is unique about these kind of attacks. And basically, we'll talk about top cyber attacks, top attack verticals, the hacker groups, what's special about one of them that is very unique, and some real attack stories that we have seen, again, throughout our scrubbing centers around the world. And then we will take it further. So first, top cyber attacks. First of all, the point of sources. What we are seeing all around the world, where we collected, our intelligence, our attack stories, are where the scrubbing centers are located. Some of them are scrubbing centers, some of them are deceptions agents that we implemented or deployed around the world, and where we see those attacks are into our, let's say, next generation honeypots. Okay, so we have some scrubbing center in US, in Americas, in Europe, Africa, and Asia Pacific as well. That's where we see the attacks and the attackers group. In different regions, we see some attackers group that are more nominated or more the majority of the groups, and some of them are in different locations or different regions. This is a nice slide to see, especially not worldwide view, but Central Eastern Europe, daily activities and related to large DDoS attacks. Network DDoS attacks, application-based DDoS attacks, and you see the daily activity. So, the peak is around 30 events per day. Okay, this is what we see, the daily activity from March 25 to, basically the last year, but all large-based attacks. Okay, not a specific one or vulnerability, incident, a specific incident. This is our large campaign generated to large organizations throughout Central Eastern Europe. The next one is difference between, the network-based attacks, what we see in the last year, and web application-based attacks, or web DDoS, what we call web tsunami, web DDoS, HTTP floods. They are all the same, different names to the same attack. So you see the growth are more than 150% of the network attacks, and the increase of the web DDoS is more than 100% as well. So 150 network attacks are the majority of the attacks worldwide, still heavily. Although it's, let's say, a classic DDoS attack that you know from the 90s. Nothing is new over there, but still relevant in today, and you see the growth in 2025. Okay? Now, everyone knows what is the difference between network attack and web DDoS? Raise your hand. Okay. So it's all about the volume, right? On the network attack, the volume is in the bandwidth, in the throughput, right? Can be 100 gig, 500 gig, 1 tera, 10 tera, right? Terabits per second. The intention is to consume or to saturate your internet pipe with junk traffic, right? That's the intention in network DDoS, and this is not you, this is, an attack from the 90s. Okay? The technique, they're mostly used, carpet bombing and UDP floods. This is, layer 3, layer 4 from the network protocols, generate a lot of packet-based, right? A lot of packets to saturate your internet pipe. In web DDoS, on the application, it's a different prisma. The spectrum is not to consume or not to saturate your internet pipe. It's relatively low volume in terms of bandwidth, because the attackers or the hackers are generating a lot of requests, so the request is relatively small, but millions of requests, right? Millions of requests, sometimes millions, multi-millions requests per second that saturate not the internet pipe, but your application server. The server is overwhelmed with millions of requests per second. That way, they are saturating or making or creating a denial of service on the web server itself, on the application of the web server, or specific resource on the application server to bring it down. So the network is still up, the infrastructure is still up, but the server itself is completely down because he is not able to respond to a lot of requests, right? Roughly the biggest server or the powerful server that you have today can handle roughly around 5,000 requests per second, not more than that. And that's the biggest one. I don't know, maybe Amazon or eBay or, sites like that. And here, on the web DDoS or web tsunami attack, we are talking about millions of requests per second. Okay, so these are the differences, between them. Later on, we will speak about, detection and mitigation, and later on, with Marco, we'll speak about the technical specifics on these kinds of attacks. That was the DDoS. On the application level, the web application and API-based attacks, you see the growth on 2025 on the vulnerability, right? The light blue that you see here are related to vulnerability exploitations, zero-day attack. Zero-day attack means, anyone? Yep. True, fantastic. So zero-day attack means that there is no signature yet on the security vendors. If it's the endpoint protection, if it's the firewall, whatever it is, there is no signature. So it means that you need to have a machine learning, a behavioral-based detection system that is able to detect that there is a malicious activity here, a malicious transaction. Okay, and by doing that, then once you have the detection in the system, you are able to mitigate, right? You cannot mitigate what you cannot detect. So you see really the growth in 2025. Most of the attacks on the web application, on the API, related to vulnerability exploitation, zero-day, means there is no signature in the system. You need to understand that you need to have a system that is not based on signature only. The classic web application firewall that you have currently in your network is not able to, if it's not capable of having behavioral approach, machine learning approach, learning your activity, learning your application, is not able to keep up with this kind of attacks. Again, because there is no signature. Okay, I'm repeating myself. The next one, what we see, bad AI bots, right? Bots are now not only a machine, but AI machines. And they are working 24/7, right? They never sleep. So we do see, the correlation between the AI technology and the agents that are out there and the growth in 2025. 2027 is next year. So yeah, overall, 91% of the bad AI bots related to the application and related even to the user activity, right? We are not on the WAF level here. We are not on the transaction level. We are not on the request level. We are on the user level, how the user behaves. Okay, and we will speak about that as well. So we are fighting against ecosystem, not scripts. There are no scripts that are doing such an activity. I mean, if there is a script that is capable of AI, this is a machine, right? Learns the application, learns your API infrastructure. Everything is about API today, right? 90% of the internet traffic is API-based. Everybody knows what API, right? I don't need to say. Okay, so 90% of the internet traffic is API. Most of your application today, or the mobiles app, are using API. Okay, so those tools, those attacker tools, are using AI algorithms, see the response from the server, from the application, and respond accordingly. So there is a chain, you know, it's not a script, it's a script. Basically, it is a script, right? It's a machine that runs a script, but learn your response, your server response, and act accordingly. Take the next action accordingly, again, in order to infiltrate your system, your application, your organization. And everybody is talking about agents. So we are in transitions from the proprietary protocols or connectors into standard MCP protocol, ACP protocols, and it means that we need to defend, or we need to at least understand who are the bad bots or the bad AI agents. We already know that there are some bad AI agents out there, so we know first that we need to understand who are they, how they behave, and what is a good agent. Okay? ChatGPT, right? OpenAI, and others, maybe they are good. I want to allow them to my organization. Still, I need to control what they are doing, but I want to be able to detect them and see, okay, this is an OpenAI agent, I want to allow. The other ones, malicious ones, I don't know this agent, I want to block it. So I need to understand first who are the agents. Some agents are out there in the wild, in the cloud, in the public internet. Some of the agents are inside my organizations, right? Everybody is talking, all the big banks, all the governments are talking about implementing or deploying agents within the organizations. A private agent that is able to take actions and improve, you know, the efficiency of the employees or the users. So we are going there. Next one, humans versus machines. So we understand that, first of all, lower time to exploit, right? The attacks, what took a human being to exploit, right, from the vulnerability with the CVEs, everybody knows, right? Takes times to generate or to create an exploit to the vulnerability. So what took our, you know, human being days to create an exploit took machines minutes. So as soon as there is a CVE, a new CVE, it takes minutes to generate exploitations, and from there, easy to infiltrate your system, your application, your server. Okay? And again, the last one, I like this one, the machines never sleep. Right? 24/7, you let it run, you tell him what to do, you tell the agent what to do. I want to infiltrate this system. He learns the application, learns the vulnerabilities, create exploitation, and boom, they are there, they are inside. Very nice. Okay, so how did we get there? How did we get here to API protection, API security, AI agents, a lot of applications around us, mobiles? Complicated, right? I remember, you know, back in the days where we had a static website, and we will see that, just to show you where we are in terms of the, you know, the waves, what we see the internet. So we started with the network economy back in the 90s with, you know, the DDoS, that is still relevant today, but the network DDoS. Then the web economy with our, let's say, classic or legacy web application firewall, where you had just a checkbox on the firewall, right? Or the bot management. And today, We are talking about API economy, API security. By the way, not API protection, API security. Different world. And we will speak about it in the technical session, the differences and what are the capabilities of API security. API protection is what you have today, probably. Everybody has API protection, maybe on the web application firewall, maybe on the firewall itself. Yeah, I have API protection, right? Because I know how to inspect, the transaction, the API transaction, and that's it. But it's not the overall API security. We will speak about it. And the AI security, that we know how to protect the agents itself from agents and towards the agent. Okay, so we are somewhere between the API security and AI security. We are going there, right? The AI is also based on API. Okay, so again, how did we get there? The evolution of the web application architecture. So we started in the 90s, with a static website. You see the gray hair. I'm old enough to know that we had the HTML, right? Static web page, no API, no third-party connectors. Everything was simple, static. No videos, no GIFs, no nothing. No security, right? Maybe only the infrastructure, like we said on the DDoS. Then we started, with more PHP, more dynamic web page, dynamic resources. And over there, we needed our basic WAF. So DDoS on the 90s. Then we needed the DDoS, the web application firewall, but the very basic, right? Because still, the website is still static. Then we moved into microservices, and still a single page, but more dynamic, connecting to other websites, but it was a single page, meaning the backend and the front end are still the same server, right? There is no distributed application. And then we needed more advanced WAF and API protection. Not yet API security. Okay? Still, microservices still relevant today, but this was the beginning. Then today we are talking about, the API economy with distributed websites or web applications where all the applications are basically not on single server, right? They are all distributed. Some of the application can be on-premise, part of the application can be on the cloud, in the public cloud or private cloud. They are all distributed. They are getting resources and data from other websites, advertisement, everything through API. Now with the agents, talking to themselves, right? I heard 2 weeks ago that there was an agent, I don't remember which organization, but the analysts or the scientists were able to see that the agent itself created a social network between themselves, and they were talking in a different language. So we don't even aware of this. The agent itself, all the agents created the network, a social network between them, and we are not there. Interesting. Something to look forward to, right? Okay, so we are there, the agent economy with API, with distributed websites, with the API security that we need. And that's how we got here. Everybody is familiar with that slide, right? This is more or less how you see it. Okay. So the next one, top attack verticals, what we see. The first one is government. Everyone likes them, right? So that's why they are in the top. Okay, so government, manufacturing, although you see here the telecommunication, service providers, telcos are relatively low number. They are basically getting all of the attacks, right? Because all of the finance, transportation, government, they are all connected to the service provider. So they are getting portion of the attack. Okay, so government, transportation, finance, large, and we will see examples on that as well. Hacker groups. Anyone can guess who is the top attacker group that we see? Again, related to Radware market, where we see on DDoS and web application and API-based attacks. Anyone can take a guess? Libra. And? Let's see. No name. Right? No name 057 is our favorite. Big portion of the attacks, and they are mostly generating web application, sophisticated web application-based attacks. Okay? And anyone knows who are they? So they are pro-Russian. Okay, application, large-scale, HTTPS flood, web tsunami. So again, we can see that they are mostly, attacking the government. Pro-Russian, the conflict, Ukraine and Russia, is still happening, it's still there. And they are being strong. Radware is protecting the Ukraine government, so we are getting a lot of these guys. So interesting to see what they are doing. They are using, the attack tools you see here. You can find it on GitHub, Google it, Project DDoSia, the attack toolkit that can generate from the network DDoS to application DDoS. They are all there, publicly available. Okay, some real attack stories, and I have 5 minutes to finish, but we can discuss it later. You are more than welcome to come to our booth and discuss further. So first of all, why web DDoS attacks are difficult to detect and mitigate? First of all, they are all encrypted, right? It's all, well, not SSL, but TLS. They are all TLS-based. Everything is encrypted. So if you are not able to decrypt or open, the TLS layer, you are completely blind. Right? This is the first thing. Everything is encrypted. So all the requests, all the web requests are legitimate, looks like legitimate. Second, you cannot use the classic web application firewall because, again, everything is legitimate. All the transactions are, everybody knows what is WAF, right? Web application firewall designed to inspect a malicious transaction, right? If all transactions are legitimate, the web application firewall is completely transparent, it's completely blind. And in Web Tsunami, all transactions are legitimate. So the WAF is not able to even detect it. But even if you detect it and you want to rate limit, you are blocking legitimate traffic because you're just doing a rate limit. Rate limit is technology from the 90s. We are not there. We want to block the attack and forward the legitimate requests. We cannot use IP blacklisting because the attackers or the bad actors are using large botnets, 10, 100 of thousands of IPs. This is not an effective solution. Geo-blocking is not possible. They are using, a local botnets, a local proxies. So you cannot block, other IPs outside of Hungary. They created the botnet in Hungary as well. So you cannot, so geo-blocking, again, is not effective 100%. Some of the attackers can be blocked outside of Hungary, but maybe 25% of the attack will be within Hungary. So it's still not an effective one. Manual filters, not relevant. You cannot keep up as a human being, create filter, another filter. By the time you create the filter, the attackers are changing, right, the attributes and the properties of the attacks. So you cannot rely on manual filters. And CAPTCHA is no longer, right, is ineffective. There are CAPTCHA farms. Everybody knows how to pass them. It's not a valid solution anymore in the past 5 years. Let's move fast, 2 minutes. Some of the web attacks that we are seeing in Europe. This is an example, 1 million of requests per second. This is from our portal. Large, major public financial service in Europe. And what we see is a real-time signature that we created on the fly. Right? No signature, zero-day attack, no signature in the system. In real time, we are able to detect, create a real-time signature, and block only the malicious transactions. Okay, another one, the rate is increasing, 2.5 million, again, on major hospital in Europe. Same thing, created a signature, no impact on the hospital. And again, 2.5 million requests per second. Again, 5 million now. Okay, 1 hour on major European university. Again, no signature in the system. We are able to detect and mitigate it. Just increasing the volume. 5 million, 10 million requests per second. This is, no server can handle this. Okay? Again, all the requests are completely legitimate. Again, there is a lot of algorithm behind this. We can discuss it in details, but they are there. 12 million. This is a nice one with the bad AI bots. So we are able to, again, detect the difference between the bad bots, right, and the legitimate bots, right? Some of the bots are legitimate. Google bot, Facebook bot, I don't know, maybe yes, maybe not, but still I'm able to detect, okay? And different categories for the bad bots. A large online business protected by Radware from malicious AI bots. And the solutions from Radware, what technology we are using, different algorithms, different solutions, different perspective with AI machine learning algorithms to really protect your data center. Data center can be a physical data center, virtual data center, public cloud, private cloud. We are there. And I'm running out of time. And last one, a nice quote I like from Sam Altman, you know, the CEO of OpenAI. What is the biggest concern him is that, you know, the bad actors could possibly create a super intelligent AI agent before we are human beings, you know, rest of the world is able to defend against it. And the biggest concern from his point of view, it's already there. We are there. They are deploying, they are really generating super intelligent AI agents. And with that, I will thank you.